Hello everyone. In our last tutorial we have discussed basics of generics in Swift programming language. What is the use cases of generics and what are the advantages of it. For example, if you are having functions where only the data type that needs to be changed. For example, there is a swap method which is for integers, strings, all the primitive data types. So instead of writing separate functions and each and every primitive data type, we can write a generic function using this placeholder type name. Okay, and we have discussed why we go with T, and array will be having element and dictionary will be having key, value and all, and why they are of upper camel case, correct, so that we can, if it is upper camel case, we can detect them as placeholder type names, correct. So using all the redundant code can be reduced or completely removed using the generics. So this is a generic function example we discussed, and also the same with generic model. For example, if you have a collection, instead of having a collection for integers, strings, doubles or your custom data types, you can have a generic type by passing placeholder type like this, okay, where you define like this, where you return like this, and when you are defining it you do like this, correct, my list int something like this, correct. So and also for protocols, let's say when you have a chat protocol, instead of one for the text chat, why? Because it is a string, audio chat which is a data string, and video data which is again a data, binary data. So instead of that you can have a generic protocol, so where generic protocols go with associated types, and we give this placeholder using the type alias, correct. So and this we call it as generic protocols, and we can define models conforming to the generic protocol, passing the data type that they want to send. So that's where basically generics at a very basic level, where we can define, we can write generic functions, we can write generic models, and also we can write generic protocols. These are some examples of generic protocols where we define, and we can have one or more of associated types, and we can pass associated types like this. So in this video tutorial, let's discuss couple of advanced concept of generics, where the basics we cover. So advanced concept, if I have to say, so one is type constraints. This is very important. Why? Because it's not always like we can go with normal. For example, let's say is equal. So if you have integer comma b integer, then I'm just checking whether both are equal or not. Of course you might have guessed it, where it's just as simple as return a is equal to b, correct. So for example, it's very difficult for me to write it for all the, for example, let's say all the primitive types. This is one thing, I'm not going to explain that, this we have already discussed. We could write a generic function for this. So for example, if this is the case, let's say instead of okay, let's say if it is a custom step where we have our user, let's say, I think we defined user somewhere in this yeah, for example, okay, it's a user. So I go down, let me take a class. For example, let's say student, let's suppose this is class, okay, and instead of this, for example, student with name, student with phone number, okay, it needs, okay, name, let's say this, phone number, let's say this, and let id is equal to some 0 to avoid the initializer. For example, if this is the case, if this is the custom class, now what happens? Instead of this, for example, let's say I have a I need to write a generic class, so I would go like this, correct. So I would be going like this, correct. So if this is the case, then just to understand So I can't. Binary operator cannot be applied between two operands. Correct? Why? Because here I can pass my custom type also, not only primitive data types, I can pass custom type also. Now this cannot be applied. Why? Because if there are custom types, then this will not be executed. That is the reason it is complaining, saying equal to operator cannot be applied. Why? Because until unless they conform to something called equatable protocol. Correct. So basically that is what it is complaining, saying that until unless these are conforming to equatable, I can't do this operation. So we need to pass only that stuff which conforms to the protocol. So that is the reason it is again started complaining. Why? Because the student we have passed is not conforming to the equatable protocol. The moment we pass it, this will be silent, but this will start asking. Why? Because equatable stubs we need to pass it as long, let's say as long as the id is equal to both the ids of the students are equal. Let's say they are equal. So this is the scenario. So this is nothing but I have a type, I can pass a type, but there is a constraint. I can pass any type, but there is a constraint. These we call it as type constraint. Correct? Now I can pass anything to it, but they have to, that particular model it has to conform to the equatable protocol. There is a type, but there is a constraint. Here conforming to the equatable protocol is nothing but the type constraint. So I hope this is clear. This is the first concept. We usually see that in our daily code bases, where generic types conforming to the protocol, or it could be conforming to or a base class of something else. Correct? So that also. Okay, for example, if it is not equatable, let me say, like for example, I have a class user. Okay, just an or human, let's say, just an example. If I say like, okay, mine, this thing has to be equatable. Okay, let me write some composition here. Okay, let's say only it should be of base class of human. So what it is complaining is, just a second. There is a composition. I can write like this. Okay, let's see if it is complaining or not. Yeah, this is the composition. Okay, so that means I have two constraints here. One is it should be a base class of the type that you are passing should have a base class as human or of type human, and it should be conforming to equatable protocol. Now, as if I build the project, so as you can see, I was able to pass the student. Why? Because it is conforming to the equatable protocol. Now, if I remove this, just to show you, let's say, let me pass a, now let me build the project. Now let's see if it is getting succeeded or not. Maybe at runtime it will complain. Let me quickly write something called struct test inside it, just to test our what we are writing. So for example, let me is equal. Correct? So this is the function we have written. Let me pass student and student. Okay, if I build it, so it's not complaining, that's fine. So basically there is a composition. There is a composition also we can do, but I'm not 100% why it's not working. But basically, if we can also give, like, it should be a base class of the if t we are passing, it should be of type human actually. Okay, let me remove this. That is the reason it is, and let me say it as, yeah, now I get it. Human and equatable. The type you are passing should be of human class, and it should be of equatable. Now see, global function requires that student inherit from, now it started complaining, inherit from human. Now what I need to do, okay boss, okay, if you say so, okay, human. Yeah, now it is satisfied. Okay, just a second. Superclass human must appear first in the inheritance. Oh, okay, first base class, and then the so that's the reason it is complaining. So now it's not complaining. Why? Because student is conforming to both constraints, correct? So this is the composition we can write. I hope you understood. These are type constraints. Okay, that is type constraint. So hope it is clear, where we can give the composition, and we can add some constraints on the placeholder saying that it has to be this and this. Okay, now the second thing is adding constraints to an associated type. So associated types, we use it in the case of generic protocols. For example, let's say I have a class called director, I have a class called employee. Okay, now I have a container which is a generic protocol. Now I have this item, this handle. Now how can I add constraint, adding constraints to associated type? How can I add constraints? So same, like I can pass something like, you can pass me anything which is equatable, correct? So as you can see, for example, if you have to conform to any protocol, for example, container, let's say class product, class products list, let's say products list. Now which conforms to the container. Now it will start complaining, saying you need to add the steps. Item, let's say I give director, employees list. Okay, let's say employees list. For example, if I give does not conform to the container. Okay, protocol stub. Okay, count is there. Now has no initializer. Okay, let's add initializers as well. Okay, initializers also have added. Now let's see if it is complaining or not. So it is not conforming to the, okay, let me add this as well. So initially it is 0, correct? Does not conform. Why? Because does not conform to the protocol step. So it is keep on complaining that it doesn't get an type alias which conforms to the protocol. That is the reason it is keep on complaining. Though we have given an item, it is keep on complaining. Why? Because the director class is not conforming to the equitable protocol. If we don't add any constraint, I think it will not complain, correct? Director is fine with it, correct? But if I add the constraint, it is nothing but a constraint. So what we are doing, adding constraints to an associated type, like this we can give. So until unless I pass a class which is of equatable class, this will not stop complaining. So yeah, here also I need to change. I think that is the reason it is complaining. Now it is successful. So same. It's sorry. The way we added constraint to a type placeholder, it's the same way as we can add a constraint to the container. Why? Because sometimes we, until unless they conform to the equatable protocol, we can't do the find and search operations, or correct, list container dot contains, correct? So these operations cannot be performed. So that is the reason we sometimes add the constraints. Okay, very good. And instead of this, for example, let's say instead of passing this, for example, I want to give I want to give an extension to my protocol instead of restricting at very high level. Correct? If I restrict it, not all the containers can implement this. Instead of this, what I can do is I can do with a container where like this also I can give, where item conforms to the equatable protocol, so that whoever conforms to the equatable protocol, I think they just a second. So let's keep this. So whoever conforms to the equatable protocol, they get something called, let's say we add something called append safely or something like that, where technically they pass an item and it conforms to the item, and we just check saying if list dot contains item. If list doesn't contain this item, then only list dot append item. So this applies. That means only those models which conform to the container protocol, and whereas the data type is conforming to the equatable protocol, they can only have this append safely. Correct? So if I see this, for example, this employee is conforming to the equatable protocol, and for example, and let me take another for example, directors list. Okay, this also conforming to the protocol container, but count 0 and director direct. Okay, there are two classes now. Now let's see for example, if you could see directors list dot append safely, you will not get it. Why? Because its item is not conforming to the equatable protocol, where we have written these, we call it as generic extensions with a generic where class. So these we call it as extensions with a generic where clause. Extensions with a generic where class. So like this, using the where classes also you can write saying, so this director is not conforming to the equatable protocol, but employee is conforming to the equatable protocol. If you can see append safely is coming. So this extended method can be applied to items. So like this, but earlier directors list was not able to conform to the protocol. Why? Because director was not conforming to the equatable protocol. Why? Because we have restricted at this level, associated type level. So instead of that, what we have done is just a tweak, where instead of restricting at associated type level, I have just given the restrictions in the extension. Correct? This is also very important. So we are not supposed to be blocking a complete protocol if you need that item, so that you can add a method like this if it conforms to the equatable protocol. Instead of that, you can go with extensions with a generic where class. Correct? Also, this can be in a way, we can write like this as well, or there is another way. Okay, the another way is contextual where classes. Contextual where classes. So okay, contextual where class. So what do you mean? For example, instead of doing this, what we could do is, okay, instead of you doing this in the extension, for example, instead of this, I can do like this also, where item conforms to equatable protocol. So as we are redeclaring, it is complaining, but I can comment this so that it will not complain. Let me build it. There should not be any errors, and still this works. Now it's not redeclaration, but as it is conforming, as my employee list is conforming to the equatable protocol, I could still get, sorry, sorry, I could still get append safely, whereas the same applies again. Sorry, okay, directors list dot append, it will not. Just a second, okay, let me write it here. Directors list dot append safety is not at all coming. Let me build it just for directors list. It is, sorry, directors list dot append safely is not coming. Why? Because the constraint is same whether you apply it as for the generic where class, at extension level you applied. See, at what level we are applying the constraint is is just what I wanted to discuss here. At associated type you can apply, that means you are restricting complete protocol. At extension level you can apply where you are restricting complete this extension, whatever is defined in this extension method will only apply if item conforms to the equatable protocol. Or contextual where classes I can apply where instead of restricting the extension I can write like this, and I can write another method saying append, something like this, right? So this method applies to only which conforms to the equatable, and this method, let's say some test method or something, this applies to items which even if they are not conforming to protocol also. So that's basically what I wanted to discuss, and there are two types when you are restricting: associate type level, extension level, and contextual where classes where within an extension you are restricting when writing the method. Okay. Now one last, I hope this is clear. These constraints are very important. For example, type constraints I can apply on the type wherever, and it can be a base class or it can be a class, we can say, and we can say it's a protocol, and you can say like it is hashable, and you can say like it is something. So this using the AND operator we can write the composition. That means it has to be a base class of it is to be of a class of human or a subclass of human, and it should conform to the equatable protocol both. Then only I think you can use this, correct? So basically like this, and you can add constraints to an associated type at a protocol associated type level. Here you can apply the constraint, or you can apply to the extensions with a generic at an extension level, or you can apply it an contextual level. So one last thing is, I hope everyone knows about subscripts. So subscripts are very important. That is the reason, if you can see, if it is an array, you are able to do this. Why? Because of the subscripts, correct? So subscripts also, for example, let me write a quick subscript for you. For example, there is let me directly write generic dictionary where you can pass. I mean subscripts we generally write it for different data types, right? So instead of that I can go with generic subscripts where generic, if it is a generic dictionary, of course key should be of hashable, and value you can pass it as a generic type. And okay, if as this is a subscript, so we usually have dictionary, correct? And which is typically of type key comma value. Let's initialize it. So this is the dictionary key value where key should be of hashable. That is the reason I made it. It could be string, it could be an integer, or it could be of your custom hashable type, anything you can pass it, and value could be of anything. So I have a dictionary. Now from this has become a generic subscript. Why? Because these are the type holders, two type placeholders I have. One is key, one is value, where I have applied, as you can see, this is a type hashable is the constraint applied, correct? That is what we just, that is the reason subscripts also I wanted to discuss now. So I have two placeholder types where one is confirming, where a constraint also I was able to apply. Okay, now the subscript pass, we all know it's like a normal method where it is like you pass the key and it will give you the value, that is the subscript, correct? A dictionary or array, that is the concept of subscript, where in our case we wanted to return a generic type. In that case, as it is like a normal method, you pass the t, correct? Why? Because value we don't know, that is the reason you can pass it, it could return anything. So as it will have gets where we return, so it is our dictionary of key which is hashable, so that it can take care of duplicates, and we typecast it as t. Why? Because the return type is t, which is also again generic, we don't know what it returns, correct? So and it should be having technically the set also. So sorry, let me set. So set is if there is a value, I'm sorry, so subscript by default gives value as new value. Subscript we will, so that's how we set it. Dictionary of key is equal to value, whereas dictionary it should be of type value, that is the reason we are typecasting it to value type and then putting it inside, correct? This get, of course this get also I think we can typecast it to value, but to make it more generic, so we did it like this. Now this has become a generic subscript. Now you can see I can pass any type, in the sense I can pass typically any kind of data, int, string, int, custom type, only the constraint is the key should be hashable. Of course that is the requirement in any dictionary, correct? So these are bit advanced concepts of generics, which seems like a bit confusing or a little hard, but these are very easy and very useful. Of course I am writing the generic, but if my type has to conform to, if I need to apply some constraint because of my requirement, then I think applying these, knowing how to apply these constraints is very important to know, and these are very important for interview point of as well. I hope this post is useful. Thank you.